Hey guys, today I will show you a shortcut for expanding brackets. I'm going to specifically focus on square of binomial, something like square of a plus b, which a plus b happens to be binomial, two terms added or subtracted together. There is a formula, there is a shortcut, if you will, that allows you to expand, to open up, to remove the parentheses when you are given something like a square of the binomial. And all it says, all you need to do is just raise square to the second power the first term, so a squared plus double twice. You need to take this double of the product of these two terms, a and b, and you add the square of the second term, b squared. So if you don't remember this formula, so basically all you do at this point, you take this a plus b and you want to multiply a plus b by itself twice. Basically that's what your second power stands for. And if you do, so you end up getting the normal, the usual, the standard way of opening up the removing parentheses. So you want to take the first term a, you multiply by this first term. In the second parenthesis, so a times a gives you a squared. Next one, you wanted to take this a and multiply by the second term in the second parenthesis, so it's gonna be plus ab. And the same rule applies for the second term in the first parenthesis b, so you want to combine it, the first term in the second parenthesis, the second brackets, and to the second term in the second parenthesis. So b times a, it's the same thing as a ab. And you want to add b times b, which gives you just b squared. And at this point you want to collect these two terms, so you end up getting a squared plus 2. So since they're precisely the same thing, it's a like term, so gonna be 2ab plus b squared. So you end up getting precisely the same expression. So many people don't use this shortcut. They don't remember, they don't know, or I don't know why. For me personally, I would never do this because it's tedious, it takes time, and time is precious, especially when you sit for a proper exam and you run out of time. So it's a good policy, it's a good rule to just remember this shortcut that basically saves time. So when you do this expansion, you might make mistakes somehow. So in a nutshell, it's a good policy to just remember this formula, especially if you are not given just a and b. If you're given something like more complicated, something like 2x, 3x, a coefficient in front of your term, in front of your variable, and I will get back to these examples in a while. A quick aside note, if you are given minus instead of plus, your two terms being subtracted, you want to change only the second term. So second term, which is basically the double, these two times the product, comes negative. So you want to change negative over here. The third term in this expansion remains the same. Now let's put it to the test. Say you have x plus 3 squared and you need to expand this binomial. You need to open up, remove, get rid of parentheses, whatever you like. So all you need to do is just apply this formula. All you do is basically match up. Your a is x and your b is 3 at this point. So this is your b. So all it says, you want to raise to the second power your first term, which is x. So go ahead and write x squared plus, since you are given addition between your terms, double twice. You want to multiply these two terms, so x times 3 or 3 times x. And again, at this point, if you could do these things in your head, more power to you, go ahead. And I'm just wanna emphasize and spell everything out. And you wanna add the second power of your second term, so 3 squared. And all you need to do it at this point, you just wanna clean it up. So the first term remains the same. it's still x squared plus 2 times 3, you're gonna left with 6, and you wanna keep this x, and plus 3 squared, that would leave you with 9. So that's gonna be your final expansion for this binomial. And again, if you want to check it out, so you want to take this x plus 3 and multiply by itself, like I did before. So you're gonna end up getting precisely the same expression. Fortunately, life is not so easy and can humble you like that. Say you had 3y minus 1 raised to the second power and you need to expand it. Now, as I mentioned before, look at this. Your first term happens to be not just a letter, not just a variable. It's 3y. You have this coefficient. So your a, if you want to match and fit it into this formula, your a is going to be this entire 3y. And your b is going to be this 1. And notice that we have difference between terms. Anyway, you want to apply this formula. All it says, you want to take this a, this entire a, which just happens to be just 3y, and you want to raise this 3y to the second power. Notice I put the parentheses. I bracket this 3y to the second power, because after, when we are going to clean it up, so I'm going to raise this coefficient also, this coefficient in front of y also needs to be raised, gets to raise to this second power. I'll get back into this in a while. You want to subtract, since your formula says if you have minus between terms, so you always want to take away minus, double, and you want to multiply these two terms, so it's going to be 3y times 1, and basically you can ignore this one at this point because it wouldn't matter at the end. And you want to add the square of the second term, so it's going to be 1 squared, and again 1 squared is just 1, so you could basically write just 1 instead. And you wanna all you wanna do is just you wanna clean up this house. You don't wanna leave it like this. So again, as I mentioned before, pay attention, because many people forget to raise 3 to the second power, and it's vitally important. So you wanna raise them separately. 3 squared, that would leave you with 9. Go ahead and write it. And y squared, you're gonna left with y squared minus 2 times 3, you're gonna left with 6y. You wanna attach this y at this point, and you still have this one hanging around. So that's gonna be your quadratic expression or your expansion for this square of that binomial. Alright, with this being said, I hope it has been helpful to you. Huge thanks for watching and enjoy your brain. I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you'll not miss out my new